Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let's start the session. I have taken a full bridge control rectifier with RL load. First of all, you should know about the RL load, what is the current waveform in RL load and what is the current expression in RL load circuit. Let's assume a circuit is circuit with switching RL load connected. Switch is closed as T is equal to 0 and Vs equal to Vm sin omega t AC supply. Then what is the current expression in the circuit? Apply KVL. We will find I Vs equal to Ri plus L di by dt. Voltage drop across the resistance and inductance. This is a linear differential equation. We will find Vs is a Vm sin omega t this is a linear differential equation. You can solve this one by dy dx plus py is equal to q type. You know about this one solution is a integrating factor into y integration of integrating factor into q into dx plus some constant k, where integrating factor is e की power integration of px dx. You should apply this one to calculate the current expression in this circuit. Find integrating factor e की power integration of p is r by l in dx x is equal to t in the circuit dt e की power r by l into t is the integrating factor. Then next part is this one, integration of integrating factor into q. Written separately this one, integration of integrating factor is e power minus r by l into t, q is Vm by l sin omega t into dt. You know about the integration of e power ax sin bx into dx is equal to e power ax divided by a square plus b square a sin bx minus b cos bx.
Sir,
Yeah,
sir, in the last equation of that integration factor into y, the solution of the differential equation.
yeah.
So in this on the left side integration factor will it multiply sir with y?
Yeah. This one. After that, it is going to the right side, divided by right side, divided by this one. After that, we find a k into e power something. The main equation is this one. After the final solution, you can divide by I integrating factor on right side.
Okay, sir.
After that, we find the final solution.
Okay.
You can also this one written as e power ax root of a square plus b square. We multiply root of a square plus b square in under the bracket like this, sin bx minus b root of a square plus b square cos of bx. In rectangular triangle, what a b, this one is the theta, sorry, this one b, this one is a square plus b square, and you can written as sin theta is equal to b by root of a square plus b square, and cos theta is equal to a divided by root of a square plus b square. Something apply here. Then we find this one is the cos theta, sin bx minus sin theta cos bx. You can rearrange this one like sin cos b, then we finally find sin of bx minus theta. Same thing apply, a is equal to r by l and theta is equal to same tan inverse omega divided by r by l. B is equal to omega, A is equal to r by l, x is equal to t, replace all of them. Then we find finally integrating factor like, sorry, integration of e power r by l into t sin omega t into dt is equal to e power r by l into t divided by root of r by l square plus a square plus b square to sin bx minus theta. Then if we take a LCM of L square denominator, then we find denominator L into e power r by L into t divided by r square plus omega L square to sine omega t minus theta. Now theta is tan inverse omega L by L, omega L by r. Here the angle of RL circuit. We written this one is a Z impedance like r square plus omega L square. We finally say that e power L into t divided by Z sine omega t minus theta is the final. Then what is the I? Final solution integration factor into I is equal to integration of this one like L into e power 2t divided by Z. One factor the missing Vm by L constant. So come in the picture this one. I will take in this one only e power ax sin bx. Vm by L is the other term also. Containing this Vm by L, LL cancel out, and we find it is equal to integration factor is same as e power minus e power r by L into t. This one is cancelled out. Go to multiplication of k e power. This one is cancelled out because of integrating factor same as e power r by L into t. And finally, question we find Vm by Z sin omega t minus theta plus k into e power minus r by L into t. This one is the current expression, and RL circuit is present. The switching occurs at the time. In shortcut, you can take this one like VSRL. Take VS equal to Vm sin omega t. Definitely you find a two thing, steady state value and transient value. Steady state plus transient. You will find a two factor. Steady state same as the AC analysis. Like if you current find in the RL circuit, same as find Vm by Z sin omega t plus some impedance angle minus some impedance angle phi something plus transient k into e power minus t by tau. This one is the transient effect, and tau same as the time constant of the load L by R. You can put here, then same find the same value sin omega t minus phi plus k e power so minus t by tau. This one is a transient effect of any circuit. In RL circuit, same thing in RC circuit, tau is the RC. To find a value of k, take as t is equal to 0 and I is same as 0, and switch is not closed.
Sir, what is phi?
Phi same as impedance angle tan inverse omega L by L, omega L by R. you will find a two value, a steady state value and transient value. When switching, a certain switch RL circuit switching occurs, then you find a steady state value and transient value. ST is same as the AC losses system. If you apply a AC signal to the RL load, the same will find Vm by Im sin omega t minus some impedance angle. If lagging in RL circuit, then minus of phi. If RC circuit is there, then this one is a plus phi, because the current is leading. And one transient effect.
How did you get that, sir? K.
Yeah.
How did you get that? K into e to the power of minus t by z.
Same thing, na? I calculated this one.
Oh, okay.
If you take a long method and analysis of all of things, then you find a steady state value and a transient value. This one occurs as t is equal to t is close at t is equal to 0, switch is close at t is equal to 0. That time, at exponential decaying nature occurs, as a disease value, or a current waveform like this one. At infinity, this one is a 0 plus this one is the sinusoidal in nature. Sorry. So no, original current is in a steady state. This one is a transient. Transient effect is not more than the 5 cycle or 4 to 5 cycles only. It's only a long time. Transient effect will be removed. This phenomena occurs in switching phenomena in power system. In transmission line suddenly switch on, and transformer also, because of the maximum load and domestic load is the RL load. Then this type of transient effect occurs in the circuit. You can find a value of K by putting it as t is equal to 0, I is equal to 0. Same thing, this one circuit. If at t is equal to 0, I is equal to 0, means this one is 0. Vm by z, this one 0 minus theta, means minus sin theta is phi, r of phi, this is both are same. So this one is K. Then finally K will find Vm by z sin theta. This one also known as a DC value in a signal losses system. This K is good. Then also final question of current in RL circuit. You can find here the theta. Theta is impedance angle. If the impedance angle is 0, like in R circuit, uniresistive circuit, then transient effect will not present in the circuit. So theta is equal to 0, it means sin value is 0. Then all of the DC transient effect will be 0. Only a steady state present. When in a resistive circuit is present in the circuit, only resistive circuit. If any energy storing element present in the circuit, then transient effect will be definitely come in the picture, like inductor and capacitor.
So what about the transient effect of the switch?
Switching transient effect.
Yes.
This one increase the magnitude of the current at switching time. This one highly, I think, a double effect. You know about the in transformer. I think you read this one. Double effect. Double the inductor, double the current, and at a time of switching, current will be double, like that. If a transient phenomena occurs, then current will be increased.
Sir,
Yeah.
sir, the current is double at this at the time of starting, right? When t equal to 0, as soon as the switch is closed. When you are saying the current will be double, sir?
No, it depend on this one theta value and omega t. When we will switch the voltage, switch the current. I think this one I will take Vs is to Vm sin omega t, like na.
Yes, sir.
But in practical thing, this one also is like alpha something, omega t minus alpha.
Okay.
Where alpha, this one sinusoidal signal, this one voltage. But you don't know about the zero value. When it will be zero, you go and
Yes.
sudden switch on the circuit. Then what
Yes,
will
sir.
present? This one you should you on at any position. Na? This one position, this one
Yes,
position,
sir.
this one. It depend on the
Yes,
alpha
yes.
value. If you will know maximum at maximum, and that time the transient effect will be
Transients won't be there.
yeah less.
Yeah.
Come in our circuit. In this one, same thing also apply here in the full rectifier. It means in RL circuit, if a thyristor is present like this one, current waveform not is purely sinusoidal. 0, pi, 2 pi, this one Vs supply voltage, this one minus Vs. I will draw this one also. This one plus Vs, this one minus Vs. It output voltage and output current. This one is a fire angle. If you thyristor will present, and this one alpha, pi plus alpha. Take this one as also 2 pi plus alpha. And output voltage start coming in the picture after the alpha, and same follow the input voltage. But it depend on the inductor value, where it will be 0, because of it depend on the current value. Current does not 0 sudden 0 in inductor. Inductor current will express even this one like Vm sin omega t plus some tangent effect. It is not a pure sinusoidal. It will be some transient effect also. Then you will start from here. Maximum will go at pi at only if inductor is present, but RL circuit in resistance also present also, then it will maximum at before the pi. After then this will go to 0 like this one waveform, current waveform. Then I start this one. But it will be continuous or discontinuous depend on the inductance value. It should be, it can be 0 from the alpha, pi plus alpha 0, then this one is a discontinuous. After they start this one maximum and come to the 0 at before 2 pi plus alpha. In that condition current will be discontinuous, output also discontinuous. And when current passing pass the angle pi, then voltage also come into with output and follow the current. When current will be 0, that time voltage also 0. This time is a discontinuous condition. Same thing, voltage output voltage 0. Sorry, start this one at pi plus alpha, same follow this one, and this one 0, like in a steady state value waveform. It could be 0 from here also. If you increase the value of inductance, then you can find this one also in the continuous conduction mode, like this one. Maximum, minimum, maximum, minimum. It could not be 0 also. At that type condition, the output voltage is a continuous time. This like this one. At alpha, after that this one will start conduction D1 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 D2 sorry T1 T2 conduction. In this picture T3 T4 conduction, T1 T3. It could be continuous, it could be discontinuous, independent on the value of inductance. So inductance is high. If you use a high inductive load, that could be a continuous conduction mode, output volt current. And if inductance value is low, then this will be discontinuous also in RL circuit. I have thyristor is present in the picture.
Sir?
Yeah.
Sir, when the current is decreasing, no?
Yeah.
After pi, the output voltage is still existing. Sir, if actually at this time the source voltage will reverse, no, sir. So how at that time T1 and T2 won't conduct?
The current would not be 0 na direct at sorry current not a sudden 0. It will
Yes, sir. It is in continuous conduction mode.
It should have has a path to flow the current. For inductor, it must be a path to flow the current of inductor.
Yes, sir.
Inductor.
Yes.
If an inductor will, path will not provided, then di by dt at the time of a switch off is very high.
Yes, sir.
Di by dt is very high. Because of this one, the thyristor will not be turned off. It will be continuous conducting.
Yes, sir. Which two thyristors are conducting? The T1 and T2 will be conducting
Same one. T1 T2 will conducted from here also. Yeah. Here to
up to here.
Yeah. After this one, T3 T4 start to conduct. Because of T3 T4 we will not provide a pulse no, to T3 T4. Then this one will not be off. Thyristor have controlling up on control. Off control you don't have a thyristor. In thyristor you don't have a off control. Only you have a on control. Na? When you switch on the thyristor, then it will be off when a reverse bias voltage applied to this one.
Okay. Sir, at that time the inductor voltage will keep this T1 and T2 forward bias after
Yeah.
pi up to.
Yeah. Because of this one. Okay.
Okay. Sir, what about the T3 and T4 at that instant? Will it remain off
Remain off.
even after?
No, remain off. If T3, T4 are on the same time, T1, T2, T3, T4, then this one is the short circuited. Na?
Yeah, that's okay, sir. But
Only one switch is on. You know about the source inductance?
no, sir. Sir, what I'm asking is,
Then
the T1 is T2 is the T1 T2 are conducting even after pi because of inductance voltage.
yeah.
T1 and T2 are conducting, but
Yes.
at that time itself source voltage reverses. So T3 and T4 will get forward bias by the source.
Yeah, this one is forward bias, but you don't provide you have not provided
Gate
the
pulse.
gate pulse.
Okay.
If this one is a diode, then definitely diode turn on.
Okay.
Yeah, this one diode will on, but thyristor will not be on.
Okay.
If you provide a diode here, then diode conductor start here. Only then this one is not provided. Negative spike will not come in the diode. Negative spike will never come in the diode output voltage. Output voltage negative spike come in the picture only in a thyristor. If you to remove this one, we will provide
Sir,
a
what, sir?
free wheeling diode also. If you give a path to release the energy of inductor, then the negative spike also will not come. This one is turn up, thyristor will turn up here in pi,
Okay.
at pi.
At pi.
Inductors must have a path to release energy to flow the continuous current.
Okay, sir. Sir, if this freewheeling diode is not there,
Yeah,
and the thyristors are replaced with a diode,
yeah,
then even at that time, the T1 and the D1 and D2 diode will conduct even after pi, no?
yeah. Definitely conduct.
Even though it is a diode, it will conduct.
Yeah. Even if you remove only two, T2 and T4 remove replace the both diode, then same phenomenon also occurs here. Negative spike will not present. This one will be 0. This one like that. This one is disadvantage of any output voltage will less average output voltage is less decreases with respect to continuous in sorry if a negative spike present in output, then output voltage will definitely decreases. To increase the output voltage, we use this one Spivling diode or we place a two thyristor with diode. But you have uncontrolled, a half control only. This one T1, T3 you can control.
Okay, sir.
You can express the output voltage here also. 5 to 5 plus alpha, you can integrate V output 1 by T average output 0 to T V output into d omega T V output same as sin omega T and same as Vm sin omega T into d omega T. Pi is only T is equal to pi integration of alpha to pi plus alpha Vm sin omega T into d omega T. You integrate this one Vm by pi cos alpha minus cos pi plus alpha. This one negative, you can put up first lower boundary after the upper boundary. Then you find Vm by pi 2 Vm by pi cos alpha. This one minus cos alpha, minus plus cos alpha plus cos alpha 2 cos alpha. This one is the output voltage in with a thyristor RL load. You can control output voltage by the controlling of alpha angle. Same thing if you provide a freewheeling diode here, then negative spike will remove, only this one come in the picture, and then alpha to pi only, conducted alpha to pi. This one known as a semi converter. A half control converter. Half control rectifier. This one output voltage same as 1 to pi, alpha to pi only. Vm sin omega t into d omega t. We will integrate this one to find Vm by pi.
And 1 plus cos alpha.
1 plus cos alpha. Then put the value of alpha, any alpha, like alpha is equal to 30 degree. Then find which one is greater, this one or this one. Then you find this one definitely more than this one, because I 1 plus cos alpha. This one is cos 30 degree is 0.866. Then this one 1.866. And this one is a 2 into 86. Which one is greater? This one, na? 2 into 866 and 1.732. And this one 1.866. That's one difference between fully controlled rectifier and half controlled rectifier. In half controlled rectifier, negative spike will not present in output, and fully controlled rectifier, negative spike will present in output voltage.
So, because of the flywheel diode, you are saying that it is a semi-converter, correct?
Yeah. Semi-converter, semi-controlled means a half control.
Okay.
You have not a fully controlled because of the freewheeling diode in.
Sir, it is fully controlled only, sir.
Yeah.
Because both in half control and full control the same waveform, except the negative spike.
Now half control
Then it is fully.
and semi control is same, but fully control is different. Fully controlled means only
No,
rectifier will present in the picture.
Yes, fully controlled and half controlled same waveform.
No, fully
Except
control
the
half control is different. In fully control, this one is negative spike also come in the output voltage.
So what is the advantage of the negative spike?
Only this one, negative spike, will not present a half control.
No, what is the advantage of getting the negative spike?
If you analyze the input current of this one, then only harmonics will be present in half control, a semi control, the more than the fully control. If you analyze the harmonics and means Fourier analysis you done, if you do this one, then you find the harmonics is more in a half control rectifier with respect to fully controlled rectifier. And output picture in at a constant output volt current. But voltage will be.
What is the advantage?
Yeah.
Advantage of getting the negative spike in the full control?
Yeah, this one is the more advantage of this one. Negative spike will be removed in a half control.
Yeah, that is advantage only, no? Half control
This
is
one is advantage, but one disadvantage is the harmonics.
Okay, do you utilize the negative spike? in any application?
No, this was not utilized.
Sir, when we were talking about the previous example,
Yeah.
previous analysis, you said that it may start at any point. So, is there a mechanism by which you can protect the heavy current rush probably during the start? Then,
In this one,
yes, sir. Yes.
yeah, this one have many type of electronic switches in project.
So you have to synchronize with the zero crossing.
Yeah.
Okay.
You know about the circuit breaker or something switching in a power system will present electronic switches. The electronic circuit relay is there also. To prevent this one at time of switching, and transformer switching also electronic switches project. Electronic switches, if you this one all up about the coding. If you code this one, VM is greater than in the fight maximum value, peak value, you have pi by 2 is 90 degree. 90 degree VM is maximum, na? VS is maximum at 90 degree in sine omega t. At a give if it will reach this one at 90 degree, then switch will turn on. We have simulation of this one. I have a simulation. If you want to, I show you. Effect of an inductor. This one visible, nice.
Yes, sir.
This one is a diode present only.
What is across the diodes there?
Yeah. This one's never circuit. You can remove this one. To provide infinity. They take at least 3 million.
Sir, the resistance has to be zero.
This one circle discontinue discrete time. It's, use an input voltage, sinusoidal, an output voltage. We start at 0 to pi only, and current will be in continuous relation. If you decrease this one inductance, then it will go in discontinuous conduction. Here diode present, and this one is a thyristor. This one very high inductance value. This one is output voltage. Go to negative pi, and output current will be in continuous. This one like maximum at before the pi. This one I can take this one 0, some pi, this one 2 pi. Then it will be maximum at less than pi, because of the resistance will present in the picture. If you take this one as a very less value, then it output current is in discontinuous condition. Inductive effect is less here. So discontinuous connection. When increase inductor, and it will go into continuous connection. It depend on the inductance value. All of them. This is a continuous. If you take a highly inductive means current will be continuous. Continuous will be constant. If you take a highly inductive, then the current will be constant. People will be very less. So people will be very less. For steady state, only 0.5 ampere. But a diode negative spike will happen. Yes, okay.
Sir,
Yeah.
with this method, by increasing the inductance value, how much ripple we can reduce? Output current ripple.
The output ripple current depend on the inductor and
Is
frequency.
there any?
If the frequency is fixed, then inductance value will depend. Like it have some formula to calculate this one. I am forgetting this time.
Okay.
if you take a highly inductive load at output, if you take a constant output current, then you can calculate harmonics analysis of this one. We draw a waveform. Minus minus. So an alpha, pi plus alpha, 2 pi plus alpha. And output voltage, like this. Output current, I will take as a constant, a highly inductive load. Not the input current. This one T1, T2 will turn on from here to here. T3, T4 will turn on from here to here. When T1, T2 is on, current input current, and T1, T2 on, then current will flow like that. It is in positive direction, and I will take a output as a constant current. It means constant current flow to this one in positive direction. Now IS1 T1 T2 will not. So I not. Then what happen if T3 and T4 will not? And T3 on, this one current flow like this in negative direction. When T3 and T4 on, IS in negative direction. Same is 0 is on alpha, pi plus alpha, 2 pi plus alpha. What is the RMS of this one? IS current. You calculate this one same as I naught. Because if you this one negative term, this one positive. If you square this one, then also goes to the positive. And if you calculate this one, IS RMS, the square wave you can calculate directly in square wave form. anywhere, you can square of this one, divide by 1 to where to where is the signal is found. I think this one pi plus alpha minus alpha. This one pi divided by total time period is 2 pi plus minus I naught square into where to pi 2 pi plus alpha minus pi plus alpha, same as pi divided by 2 pi. If you calculate this one, and I naught same as, and output current same I naught, RMS of input current is same as I naught, but here including some harmonics, because of the input current will not in sinusoidal. If it is not a sinusoidal, you can't say that the power factor of input side is same as a cos alpha. You know about power factor cos phi. Phi is angle between voltage and current. This one is a voltage waveform, input voltage. This one is current waveform.
Sir, for the square wave, we can calculate directly IRMS.
Yeah. In any square wave, you can calculate directly.
Sir, that pi is period from alpha to pi plus alpha.
Where to hear a present waveform will present.
Sir?
If this one this waveform present only at pi,
Yes, sir.
then this one pi minus alpha.
Okay, sir. Subtract. And divided by 2 pi is it conducts for pi radians. No?
Total time period.
So again we are taking minus I naught separately. Then why this is for?
No, total time period, na.
Okay.
This one is the for a different magnitude. If you have some type of waveform, square waveform, this one like this one, and after that this one repeated 0, same thing repeated this one like that.
Okay.
Then first one, second one, and total time period this one, 0 to time period. So it A, B, if you take this one, quantity x1, x2 and 0, x1 square plus where is the signal is present divided by total time period plus this one, like that. You can calculate RMS of a square wave.
This is only for square wave.
Yeah, if you have a triangular wave like this one, the same thing, you apply quantity square divided by 3 and present where is the present signal and total time period t.
Okay.
You can calculate this one. Triangle you can also 0 to t, 2t. If you take this one as a x, now you know about the triangular waveform RMS value. Same calculate this one. Time period is t total divided by t. Cancel out x by root 3. This one the triangular waveform RMS value.
Okay, sir.
Yeah, this one is a shortcut term. You can apply it for the long term.
Thank you.
But here the power factor, how can find a power factor of input side? And if a signal is both signal is a sinusoidal signal, then you can say that power factor is a cos phi. Phi is the angle difference between input voltage and input current. But here alpha is the phi is alpha. Alpha is the voltage difference, angle difference between a voltage and current. But waveform is not the same. It is a different waveform, sinusoidal and square wave. In that condition, harmonics term is present in the picture, and you have calculated the THD, the total harmonic distortion, or THD, a distortion factor will also multiply of this one, power factor into distortion factor. Some distortion factor also occurs. Then what is the distortion?
Cos alpha, right?
Yeah. This one is cos alpha. Phi is written like voltage angle difference between two signals only. But here is a cos alpha, power factor distortion.
That cos alpha is fundamental power factor, sir.
Yeah, this one is a fundamental power factor.
Power factor.
If you calculate this one, you can calculate Fourier analysis. You can do Fourier analysis of this form by finding an, Vn, and a naught. A naught will be 0 because of the half F symmetry. If you see this one is the half F symmetry. It's a continuous signal and a half F symmetry. Then this means a naught will be 0. If it is 0, a naught will be 0. But a and Bn you can calculate. But I calculate in shortcut. You can take a long analysis of the using formula an 2 by t integration of 0 to t xt into cos n omega t into d omega t, like this one, xt present in alpha to pi plus alpha. After that minus I naught present pi plus alpha to 2 pi plus alpha. And Bn same thing you can calculate 2 by t 0 to t xt sin n omega t into d omega t. But if you observe this one, if I shift the signal in advance, like we shift the signal here alpha by alpha, it means yt is equal to and then different thing x t plus alpha. If you don't know about the signal system, if you know signal system, then you can find easily and Fourier losses of this one. But I explain this one. If you shift this signal here plus alpha, then this signal start from 0.
Sir, if you are shifting left side, will it be t plus alpha or t minus alpha?
This one means plus means advance. You do the signal in advance. You on the signal in advance. Delay. If you minus alpha, it means delay. Delay means it go to the right side.
Okay, yes.
Plus means you signal start from
Advance
signal. Plus alpha it means if you take a plus alpha, then signal start from 0.
Yes.
If you take a minus, then it will start at another alpha also.
Later stage.
Yeah. Then
Thank
this then this one is be like that. The signal like that.
Yeah.
And you know about the square wave waveform analysis. I not. I yes, directly 4 I naught divided by n pi sin omega t. In a square wave, a continuous square wave, the Fourier losses is same as this one. 4 I naught n pi sin omega t. Because of this one, if you have signal this like that, this one means En will be 0, A naught will be 0, only Bn is present. You can calculate Bn, then find
So
out.
this IS is after shifting, right?
Yeah, after shifting.
Okay, but we have to take this the shift that is not shown here.
Yeah, after this one, you find final value. Then you can in the final value you can shift as a delay of this one signal. Is equal to 4 I naught in original signal n pi sin n omega t minus alpha. This one is the final solution. This one is after shifting. Because in signal system, this one x-axis property you cannot change the y-axis property. It means if you shift the signal from left to right, then your y-axis magnitude, your signal magnitude will not affected.
Yes, sir.
This one is not affected. if you signal shift from right to left, you can shift, but your magnitude will not affected. Same thing if you change the y-axis operation, if you take a y-axis operation, then x-axis phenomena will not change, will not be affected. It means if you
That is if a
same
DC offset.
same thing if you apply multiply by this y naught like a1 minus a1 like this one a naught, then this one will be same, but this is multiplied by a, this one here. This one is the y-axis operation, and this one is the x-axis operation. If you would take a delay advance, this one is the x-axis operation. If you multiply by some constant in magnitude, then this one is the y-axis operation. Y-axis is the different, is affected. If you multiply this one, if any signal. And if you take a x-axis operation, then y-axis will not affected. And if you take a y-axis operation, then x-axis will not affected. X-axis value. That's why I have taken directly. I just shift the signal before calculate this one. This is same as a half wave symmetry and odd signal.
Sir,
Yeah.
sir, if the original signal is having DC, if the original signal is having DC,
This one is the output signal. This one is input. This
that
one is
is
DC.
input,
DC. Yeah. DC.
input current.
Yeah.
Okay, now this IS is not having DC. So if it is having DC,
Yeah.
then we will be calculating another term now, sir, A naught.
Yeah. If you have in that condition, if a positive and negative x is not the same, it means if this one is like 10 and this one is like 5, in that condition, A naught will be also present. Will A naught also be present in that condition? If this magnitude is really same and
No, sir. Sir, what I'm asking is, that is, you say if any shift in y-axis
yeah,
will get how we need to modify the final results if we shift this y-axis. If suppose a DC is there and we are making that to be symmetrical along x-axis, that is we are doing a downshift of a waveform,
wow,
of a given waveform.
Take like xt is equal to Vm sin omega t, Vm sin t something. Okay, this one like this one.
Yes, sir.
Yeah, if you multiply by some constant a Vm sin omega t, okay, then what will be the signal? Same thing.
Yeah,
X-axis will be same, this one will be same, but magnitude will be different. This one is a Vm, this one is a minus a Vm. In that condition, A naught will be also present.
No, sir. This is okay, sir. But what I'm asking is,
Yeah.
if suppose the original waveform is having DC, okay,
Yeah,
the original for which we need to find the Fourier series.
Okay.
So if suppose we are downshifting the waveform in such a way that it is having 0 DC,
Yeah.
and then we find the series Fourier series,
Yeah.
and finally we will arrive at a final result.
Yeah.
So how we will compensate for that downshift here in the final result?
How much you downshift this one? That is the DC value.
So that we need to add.
Yeah. This one is the DC value. Like this one, if you have a this this one is with 10, this one is with you take like 8. You shift this one to
Here air will be
one. If you shift one downside.
No, sir. We can take this negative side to be 0, and then we can downshift by 5.
Yeah, this one. So then 5 is the DC value, na?
Yes, sir. No.
Like this one.
Yeah, this one. Now we are shifting this down by 5, so it will become 5 and minus 5. Top will become 5, bottom will become minus 5.
This one like that.
Yes. For this is now for this shifted waveform, we are finding the Fourier series.
Yeah, if you find this one, first one find this one. Then you find, I think this one, if you take like x, then you 4x divided by n pi sin n omega t. You find this one.
This is the final result we are getting.
Original signal this one, then simply add a 5 as a DC value.
Oh,
Here Bn will be same, sir.
Yeah.
By in vertical shifting, it will not affect the Bn.
No, you add this here, na.
That An will change, but here since it is equal shift 5 volt plus and minus, An will be 0.
Yeah. Yeah, n will be 0.
So that it will not affect the Bn.
No, it's not.
Here in the both waveform, whatever you have done, 10 volt and plus minus 5 volt,
Yes.
the Bn will be same.
Yeah.
Okay, sir.
If you calculate here, then you find a DC value something, na. If you add this value, then this value is not affected. Only Bn present. Bn present only.
Okay.
You can calculate.
So this is the concept.
Yeah. This one come in from An plus Bn, Am sin omega t plus n sin omega t plus Bn sin omega t. So n omega t. To add both, then you find this one.
Phi is your A0, na?
If this one A not 0, then Bn is fine.
Phi is your A naught.
Yeah. In
An
this,
is 0. An is 0 because it is a
look here.
odd symmetry.
You can see here in this waveform.
Yes, sir.
An and Bn both are present
Yes, sir.
in this waveform, but in this waveform only Bn present.
sir.
But final expression is same. This one.
Okay. Even though An and Bn are present,
Yeah.
but final expression will be same, na?
Yeah. Final will be same. If take a signal below this one, shift the below this one, then only Bn present, then An 0. If you take this signal, then An Bn. If you add this one, then final expression is the same.
Okay, sir.
Sir,
Yeah.
sir, if suppose a given signal is having both An and Bn components.
Yeah.
Sir, at that time, how to find the magnitude of the fundamental of that waveform?
Take A1 and B1. A1 plus B1. Only this one.
Square root of A1 square plus BN.
Yeah, this one is the RMS value.
Amplitude of fundamental.
This one is the fundamental amplitude. If you take RMS, then square of this one and divide by 2.
Square
Like
add
this one.
that and
A1 square divided by 2 plus B1 square divided by 2. This one is the RMS value.
RMS value.
Yeah.
So like
for
that.
finding peak, sir, for finding peak, just adding those two is sufficient.
Yeah.
Yes.
This one.
Like that, it will be true for all harmonics.
Yes.
Square root
Yeah,
An
this one.
square by 2, An square by 2 plus Bn square by 2.
No, this one only for fundamental RMS.
Means for nth harmonic, it will be An square by 2. Like
Yeah, if you take third harmonics component RMS, then you can same as you take A3, B3,
Okay.
like that. This one is A3 and B3.
Mhm.
This one is the third harmonic component. A3 plus B3 both.
In that case, what is the power factor? Actually, power factor of the fundamental.
Yeah. This was the different thing. I will explain.
Now, sir, if we know all the harmonics content,
Yeah.
then what will be the net RMS value of the input?
Net RMS value to waveform RMS. You can find this one RMS. Like if a waveform like this one, another waveform, then simply find RMS of that waveform. Then all of harmonics will include this one. Same thing, but you can't calculate this one because of the in Fourier analysis, total xt is given a naught plus summation of n is equal to 1 to infinity. Then
Yes, sir.
how you can add sum of the infinity term? You can't sum na. You can take
Yes, sir.
as RMS a naught square plus a1 square divided by 2 plus b1 square divided by 2 plus a2
Hmm.
square divided by 2 plus b2 square divided by
Yes.
2 as a dot infinity.
Yes.
This was the RMS.
Okay, sir.
So it's easy to calculate waveform RMS directly.
Yeah.
That is the easy term.
Can
That's
you
why
sir, explain again this waveform from waveform? You have used shortcut. Just explain again
okay,
this shortcut method from the waveform.
okay. I have explained in before in previous lecture
Yes.
the harmonics analysis of this one waveform. No,
Okay,
a
sir.
square wave waveform. If you take a square
Yes.
wave, only Vn will can calculate. If Vn calculate, you find
Yes.
as n is equal to 1, 3 as odd harmonics, then you find 4 I naught by n pi sin n omega t.
Yes, sir.
This one. But your original waveform is different
Okay.
by x axis if done.
Hmm.
Then first you shift left side, then you find x plus alpha.
Hmm.
In the final expression, shift as a minus alpha.
Minus alpha. Okay, sir.
Yeah. Then you find in the final expression is equal to 4 I naught divided by n pi sin n omega t minus
Yes.
n alpha. Then find a fundamental. What is fundamental? N is equal to 1. Then find I naught divided by pi sin omega t minus alpha. This one is the fundamental component of the input side. This one is the sinusoidal.
Yes. Sir.
You can compare this one. Like
Yes.
sinusoidal means it will go like this, like that.
Sir, you explained this one. IRMS is equal to square root of I naught square upon 1 into pi upon 2 pi plus minus I naught square into pi upon 2 pi.
This one.
That part, yeah, that part just explain again.
If you have a square waveform,
Yes.
in a square waveform, then
Hmm.
simply you add this one like that. For find a RMS value, take a root of this one, and take a magnitude of, and what time of magnitude is present.
Okay,
How
sir.
much time magnitude is present? This one, and
Hmm.
divide by total time period.
Okay.
And this one is the pi. I naught is a pi
Hmm. Yeah.
present
Yes.
for pi. Then to
Yes.
take a pi divided by 2 pi, and a
Okay.
negative term also divide, same as a pi.
Yeah.
Then pi divided by 2 pi. If you add this
Okay.
one, you find I naught.
Okay. Yes.
Then final RMS you find I naught, and fundamental RMS calculate this one.
Hmm.
Then 4 I naught divided by root 2 into pi
Yeah.
divided by root 2 is the RMS of sinusoidal. Then 2 root 2
Yes.
I naught divided by pi.
Yes.
Total harmonic distortion say that how much harmonics is how much harmonics is affected in this waveform to original waveform. Like that, IS take a total RMS minus fundamental RMS divided by fundamental RMS. So divided by total RMS.
Hmm.
Yeah, the
So
bottom will be fundamental, right?
So I think fundamental. I think I have some confusion. This one I have fundamental. What a percentage of fundamental is a harmonics.
Yes.
You take this one, then you find I RMS square divided by I1 square, RMS square minus 1. This one is the distortion factor. Value of fundamental component over the whole component is the distortion factor. If both are same, then distortion factor is 1. But if harmonics will present, then distortion factor will be decreases. Then you can take as a THD is equal to 1 upon this one is G
Yes.
square minus 1. You can calculate THD. Then distortion factor you can calculate like this one IS RMS IS1 RMS divided by total RMS. I1 RMS is 2 root 2 I naught divided by pi, where our total RMS is I naught, then 2 root 2 divided by pi. You calculate this one, find 0.9 something. To take in ideal condition, then P input is equal to P output. This should be P output.
Sir, we are taking this G for the wave shape, which is earlier on discussion, isn't it?
Yeah, this one distortion factor you can say.
For the when the I0 is a square wave or DC, I1 RMS upon IRMS, this factor is from when the I output is a DC value.
Yeah, this one. I take output as a constant output, constant current.
Okay, constant current output.
Yeah. If this is not constant, then the whole analysis will be difficult.
Difficult. Okay.
Yeah. I will take a fully as a output is voltage. Output current will be constant.
Constant. Okay.
After that, I take analysis. Then final power factor you can say G into cos alpha. Fundamental alpha is a fundamental displacement factor. Cos alpha.
Alpha 1 is the displacement power factor of the
Cos alpha is a fundamental displacement.
Fundamental displacement.
Factor. G is equal to distortion factor. How much waveform will be distorted?
This is the ratio of fundamental to the RMS.
Yeah, this one is the power factor, original power factor. Okay, this one is a 0.9 for the single waveform. Single phase control rectifier
Into cos alpha.
into cos alpha. You can calculate THD 1 upon G square minus 1. This one is approximately 48.3%.
If output is a DC value.
Pure DC value. Yeah. You can find this one P input is equal to P output. What this one you can find output. How will you come G into cos alpha? You can calculate from here. P input is equal to output.
In this case, sir, what will be the cos alpha? Cos alpha alone.
Alpha is a fundamental displacement factor. Cos alpha. It means this
The
one
angle between
angle fundamental angle between a voltage and fundamental of current
the current. Okay.
is the cos
Okay,
alpha.
okay, okay.
The same as the same as the triggering angle
Triggering.
of thyristor.
Okay, sir.
Because of this zero is passing like this.
Hmm.
Then all of component will be zero at zero. That's why alpha is the same as the fundamental.
Yeah.
Fundamental component go like this one. That
Right, sir.
this one is the fundamental component. Yes one, and we can compare this one is the total voltage. And this one is the previous assignment question. You have some difficulty in this question?
Sir, here the option second was IN1N5817.
Yeah.
Diode could be used by replacing the 1N4002 diode. This is 5817 is a Schottky diode, I think.
This one, na?
5817.
Yeah, you can use the Schottky diode and diode, but you must be the reverse voltage blocking voltage.
The Schottky diode is having less reverse blocking voltage compared to this.
Then you can't use this one. Na? If reverse blocking voltage is less than the differential voltage. V input you can go for 40 volt, I think, and input voltage should be minimum input voltage is 1.2 volt something to 5 volt.
Yes.
Then
For Schottky, the V forward voltage is less, but blocking voltage is also less.
Forward voltage is very less of Schottky diode. And all of SMPS, switch mode power supply, you learn about the converter, DC-DC converter. Schottky diode only use. Normal diode can't use that case. Only Schottky diode, because of the resistance and forward blocking voltage both are less as compared to the general purpose diode.
So why the diode is required?
Yeah. Sorry.
Diode.
This one.
When it is shorted, output gets shorted. That time this current will be getting discharged through diode.
If this one is not present, what will say?
No, why the diode is required? D2 and D1.
This is for discharge the capacitor.
When it is shorted out, shorted.
Yeah.
Capacitor
This impedance path of IC is very less. And you have used like 240 ohm and this one is in a kilo ohm, huge resistance. And whole of current passing through the IC of discharging current of this one capacitor. You charge capacitor and discharge current also na. You discharge capacitor, then the whole of current passing through like this. If a diode is not present, they passing through like this. Or this one. Output or input. If you output short, this one like this one. Input short, then this one. That's why a diode should be come in the picture. And for D1, the output capacitor discharge like this. The discharging current of capacitor is very high at the time of discharging and charging current. It is spike like that. It can damage the ICs.
Similarly,
Sir,
this
can you
D
explain one more
output.
time?
Is a
Can you explain one more time? If the diode is present, D1,
D1 display D1 is
D2,
present,
D2, D2,
D2
D2. Hmm.
D2 is present, then this capacitor will discharge through this one. If output voltage is if output voltage is a short circuit, suppose that, then this one discharge like this one, like this. Whole of current passing through the IC current diamond. If a diode is present, then the whole of current passing through like that. Then IC will be safe.
Okay.
And output capacitor D1 or D1 and output capacitor if input is short circuit, and output capacitor discharge like that. It not current flow like this. And D1 D2 both come when this one is if input is short, suppose input is short circuited, then this one current flow like this, discharge like that. Even know
Is
about
it like
the
RC time constant, sir? The bottom capacitor and the rest.
this
What
one,
is the
yeah, C2.
is it tuning?
It's an used for the filtering to make the voltage as a constant to ripple reduce it. Or ripple
Already you have
reduce.
output capacitor.
This one is the output reduce. Sorry, output ripple reduce or output capacitor.
Again, you need one more capacitor.
Yeah, this one. This one
Yes, sir.
present only for when this current will be present, adjacent current, to make the output voltage as a constant. Regulate this one. If this one is not present, input current, then you can replace this one. Okay, remove this one. Output voltage present like this one. Correct. These two are regulate the output voltage. First option V output given is a 10 volt and R1, R2 is given. Oh, is given to satisfy this one. If I adjust is not present, output voltage like 1.25. This one output voltage of IC constant voltage and present feedback resistor to make the output voltage as you wish. And R1 this both are present in output R1 plus R2 like a voltage divider divided by R2. Sorry, divided by R1 because of the 1.25 voltage is here like this. So, R1, this one R2, this one output voltage. Can apply voltage divider. This one input voltage 1.25 into total voltage. When we find R1 plus R2 total resistance divided by where the resistance present voltage. Plus if current will present and I right into R2 this one. So the extra voltage provided by the current here. If current will not present, then this term will be 0. We'll find
So
this
the
one.
current direction is reverse
No, it is same. This one plus minus.
because it is feedback, right?
Yeah.
It should go to LM317.
So 0.25 volt. No, this one, it's like this. Like
Yes, whatever the sensed voltage should be sent to LM317.
so, I am not certain how to say.
Whatever the voltage coming between R1 and R2 should be given to the LM37, LM317.
Yeah.
The correct direction should be reversed. I adjust.
No, I think current flow like this one, na? Then this voltage and this voltage both are appear in the output.
No, that is feedback, no? That R1 and R2 is giving
Connecting.
the voltage which is feedback to the LM317.
No, I think this one same direction. You can say you say like that this one is a forward. Sorry, feedback resistance. Current flow like this one. You say
Yes,
like
sir.
this. This one is a different thing. I adjacent is used to adjacent the voltage of output voltage. It may be greater than the feedback current. Na? The first one is 0, then output voltage is calculate this one R1 by R2, then find this one is the output is 10 divided by 1.25, 1 plus R2 by R1. And this one 8 minus 1 is 7. The same thing find I like a 7 also R2 by R2 by R1 by 5 this one 1.68 10 to power 3 divided by 240. I think this one is same as the 7. First one is correct. Second one can replace this one diode because of the reverse blocking voltage of this one like 20 to 30 volt only. And this voltage difference between the V input to V output and maximum at worst condition is V input if you take a 40 volt, this one 1.25 volt. This is a very large, I think 38 something voltage. Then you can't replace this one. This is a voltage VRB blocking voltage is 100 volt. This is just diode. Diode D2 can be removed if C adjunct is not used in the above circuit. Yeah, you can remove this one. Not required to discharge this one.
नाही चल
So temperature is given. So junction temperature, junction case, sink, ambient. First to find the power is the voltage difference between them, input and output into current flowing. You take a 10 volt output voltage, then you find 15 minus 10 into 1 ampere is a 5 watt. Sorry. R1 R2 is given, so then to this one. R2 by R1 is given as a 3. Then find the voltage, output voltage 1.25 R1 plus R2 by R1 means 1.25 1 plus R2 divided by R1. This one is given as a 3 and to total voltage 5 volt output. Then power is V in minus V output into current output. Current is 1. This one, the difference between them is 10 and total power is 10 watt. We can also as a relate to the temperature Tj minus Ta, thermal resistance junction to ambient. Tj is given 100, 25, Rta junction to ambient, confined. So 1 degree centigrade per watt. If junction temperature less than equal to 10 100, then Rth should be, you can take as a less than 7.5 degrees. So also correct. Last one. I think A, C, D, N is correct answer. Take I take one question related to the current assignment as a DC-DC converter, a buck converter. So is the buck converter. Any DC-DC converter, two or three thing is most important. First one is a inductor. Inductor will present. Second one is a capacitor. Flux balance and charge balance is the most important thing in a DC-DC converter. Flux balance come in the inductor and charge balance come in the capacitor. Flux balance, it means how much flux we charge the inductor and how much flux will we restore in on time period. It should be the should be release this one energy in off time period. It means the voltage valence voltage, average voltage across the inductor should be 0 and average current across the capacitor will be 0. It should be two things the most important in a DC-DC converter. If these two things not happen, then you can't use the DC-DC converter because of you. If I charge the inductor, if flux is not balanced, it means you charge the inductor and energy will store in next cycle also. Then it in some time it will be in go to saturation mode, and all of converter will be stop to working. And same thing if charge is not balanced in capacitor, then same phenomena also occur there. At a point, a charge will be fully charged and then the current will be set in 0, goes to 0 in the capacitor and it will be stop to working. It means in inductor, then volt second balance this balance and capacitor charge balance. Charge balance is dq by dt from the current second balance should balance this one. No, the voltage is equal to N d phi by dt, L d phi by dt, and charge flux balance, and this one is dq by dt, current. When we get this one, then find a current second balance. For charge balance and flux balance is a, sorry, this one N phi by dt. If you have an inductor, then you take some turns of inductor. You take a phi should be balance V into T, like this one, right? And this one is a for Q balance I into T. This one is the current balance, current second balance, and this one the voltage second balance, or flux balance or charge balance. In buck converter, there are two states. First one when switch is on, the second state when switch is off. When switch is on, then this one connected to here, that will be in reverse bias because of the V in connected here. Cathode will be greater than anode, this one will be reverse bias, current flow like this, right? Inductor will be charged. This is the output voltage. Then what is the voltage of inductor? First thing I will written here, 0 to dt time. Dt means duty cycle on time, and off time is 1 minus dt duty cycle. And what will be the circuit? Looks like the Vs, this one V naught, IC, this one IL, VL, VC same as V naught, this one I naught. And what will be the VL? VL is, if you apply KVL here and find Vs minus V naught, then VL inductor voltage, you know about the LdI by dt minus V naught, then di by d, sorry, we will leave it, and the capacitor current same as IL minus I naught. IC same is written as dVc by dt, IL minus I naught in first case. Second case, when switch is turn off, it means dt to T, switch Q is off, here switch Q is on. In first condition, Vs minus V naught will be the inductor voltage. Final voltage is VL minus V naught. Vs minus V naught, final voltage. But current flow like this, so like this. Inductor current flow, but inductor current is not 0. And that time, and di by dt, due to di by dt, inductor voltage, diode should be turned off, so turn on, because of inductor current does not go to sudden 0. In that case, this one you can also observe this one, VL is equal to Vs minus V naught
Does it mean polarity of VL reverses? When
Yeah,
switch
yeah,
it off?
yeah. Because of only V naught is present in the picture. In second time, if this one is turn on, turn off, only V naught is present. So the polarity will be reverse. This one plus, this one minus. So connected to the here. It should be greater than at time of switch off. The VL will be greater than the V naught. At that time, this one is be turn on diode, and we can conduct like this one. Full current passing through the diode. In that condition, if a diode is turned on, then
Sir,
yeah,
could you discuss in detail when the switch is off? When the switch is off, what is the voltage applied across the diodes? VL minus V naught, sir. Is it VL minus V naught? Sir?
I had to switch off. Then sudden switch
Yes.
off. Yeah,
When
yeah,
the switch is off,
yeah,
the voltage appearing across the diode is VL minus V naught, is it?
yeah. But the current will not be zero at that time.
Yes, sir.
Yeah, current will be present.
Okay.
Yeah, in that time the di by dt is very high at that time.
Okay, sir.
Then the diode will be turned on.
Okay, sir.
More negative voltage here. I think this one will be reverse. This one is
Yes,
positive,
sir.
this one negative, and this voltage is very high to the out more than the output voltage. At that time, this one will be turned on.
Okay. My question is, what is the anode potential and the cathode potential at this time, sir?
Same if you take as a reference VL minus V naught come into the picture as a VD.
Okay.
Once it will be turned on, then if you take as a reference, take only the reference voltage, then VL will be as a negative V naught.
Yes, PL is minus something.
So negative V naught, then you can say L di by dt is equal to minus V naught, and IC is same as IL minus I naught. IC is dVc by dt. Then apply volt second balance first in inductor.
So that means it will be minus 2 V naught will be the voltage applied across the diode appearing across the diode would be minus 2 V naught, sir.
Not say directly minus 2 not total voltage, but this one voltage is greater than to V naught. VL is greater than V naught, and this one will be turned on. Also in the wave form, then we will be here. The volt second valence means the voltage inductor, because the inductor voltage average voltage across the inductor is 0. Then what time of voltage? Average voltage means the voltage into time. If we take as a constant voltage in DC system, then the constant voltage into time is the average voltage. And what will be average of this one? As one turn, then switch is on, then dt is the time present. Then you can say this one VL at dt time plus VL at when switch is off, 1 minus d. will be 0. In dt time, VL is Vs minus V naught. Tt you can take a common, and in that time VL and 1 minus d time is minus V naught. We will solve this one. And find V naught is equal to dVs. This would be from 0 to 1. It means voltage will be step down. This is known as the buck converter. You take as a 5 d is equal to 5.5, which means 50% of duty cycle. Then output will be half of the input voltage. The second thing, you apply a current second balance. IC into dt plus IC 1 minus d into t is equal to 0. First time say IL minus I naught, and second time also same IL minus I naught. D present in both, cancel out, means in average IL you can take as a capital. It means average inductor current is same as the average output current. It means average IL, average inductor current, same as the average output current. It means average current passing through the capacitor will be 0. If take as a continuous conduction mode, from 0 to t on, it means dt, you apply a voltage at inductor, VL is equal to same as Vs minus V naught LdI by dt. I take I of V naught as a constant voltage for analysis. If this one is a constant, this one is also as a constant, then this subtraction will also constant. So constant voltage applied through the inductor, then current will be in linearly increased. Like di can take Vs minus V naught by L into dt. Integrate this one, and we find some constant. Current will be like Vs minus V naught divided by L to d into some time t plus k. K is I minimum current to maximum, maximum to minimum is equal, like in continuous conduction. If this continuous conduction, this will be 0. We take a continuous conduction, and then when switch is on, then current inductor current goes as a linear to the time. If you same in dt to 1 d2 to t in off time, VL applied is minus V naught, same as LDI by dt. Into minus V naught, same current minus V naught by L into dt. I take as a d, replace it with dt as some time t. Then if dt is not constant or dt is not defined, then some time of t will be increased and some time of t will be decreased. And this will be t dash something plus I maximum. This one a dash because of this time this one both are different. I will take as a 0 to t, 0 to t. If you take this one time will be different because of t dash is t minus t on. Start this t dash start from t on, after t on, no. That's why you take a t dash, then you find like V naught by L t minus t on. Final expression of this one. Maximum, this one is minus, it means this one the decreasing, linearly decrease.
What will be the I max?
I will some amount of current in continuous conduction mode, it will not be 0. In discontinuous conduction, I max and minimum both are 0, but in continuous conduction mode, it will start at in the steady state. It will start from some amount of current remaining in inductor. Charge and discharge, but average voltage will be 0. It means average flux will be 0. Where whatever will be charged, the same flux will be discharged at that time.
So in this equation, how to find I minimum and I max?
I
Will it
minimal,
be initial?
yeah,
Will it be from initial conditions?
yeah, take as the initial condition. Take as a t, as if you take as a 0 or some time, because of this one in steady state you can't define as a t like that. But if you take t is equal to 0, then I minimal will be fine. And either this one is a t on, it means dt you can take, and I maximum will be fine.
Okay.
Zero dt and t. This one is dt time, on time. This one is a off time. We take a signal here, then on. You have to IL should be, IL start from some minimum, I minimum to I maximum to I meant as a linearly, and I minimum to sorry, I maximum to I minimum. This one I minimum. You can find I minimum, I maximum current from the, if you have a delta like a ripple current, you calculate a ripple current. After that you find the minimum maximum volt current. I explained I maximum and average of this one you calculate here. Average of inductor current will be I naught It means if you can calculate average current, it will come into the middle of this one like that. I naught. Then what will be ripple of this one? We take I minimum to I maximum. Then in on time, the voltage across the inductor is Vs minus V naught. L di by dt, Vs minus V naught. Divided by, well, integrate this one for find the ripple current I minimum to I maximum. Then this one I maximum minus I minimum. This one will be Vs integration from 0 to dt time. The on time is dt into t. If this one go, this one dt, di, this one dt. Vs minus V naught divided by L into dt. Then this one is the delta IL. So ripple of current, inductor current, Vs minus V naught divided by time period. You can say there is a frequency, written as a frequency Fl. This is the inductor ripple current. If you have a I output, if you have a V output, you find this one, R will be defined, and find the I naught directly, V naught by R. After you find the I naught, then you find the I minimum as a I naught minus delta IL divided by 2, half of this one. This one is the delta IL, and half of this one is the delta IL by 2. If you subtract this one, to find I minimum, and find I maximum is I naught plus delta IL by 2. Ripple, you find this one. All of you know about this one is also the inductor. We designed this one, Vs and V naught. Or we want to find voltage, duty cycle is defined because of the output voltage, frequency also defined, then find delta IL. What is the IC? Capacitor current. In expression, in both condition, IC is IL minus I naught. If you take as average I naught, it means IL minus I naught. If you take I naught as a constant, then IL is a ripple, and ripple, whole of a ripple in inductor current goes to the capacitor. This one I naught, IL, this one I naught. If you subtract this one, IL minus I naught is IC. Then this waveform come into picture from this one is 0 and negative to positive, positive to negative, like this one. Same where this one is 0, here come here. This one IC current. This is the same as delta IL. Then total time period T. Then half of time period is in above, and half of time period is a downside charge. Then you could take this one as a half of this one, T by 2, remaining is negative, then the average current will be 0. Then what will be the change in written here? Change in the charge. Change in charge in charging condition or discharging condition. 0 to charge or 0 to discharge will be change in the capacitor charge. If you take a charging current, charging time, this one is the charge. When current will be positive, then mean that time capacitor will charge. When current is negative, then that time the capacitor will be discharged. And this one will be delta IL by 2. If you find this average charge, this one average charge delta IL by 2, this one is a triangle. You can find total change in charge, integration of I into dt, because of di by dt is q, oh sorry, dq by dt is current, then q is equal to integration of I dt. Integration of I is average of this value. If you take average, find average of current, then you find delta IL by 2, average of this triangle, half of base into height, base is t by 2, height is delta IL by 2. T into delta IL divided by 8. You can take it as F. Right? Then what will be the change in voltage Vc? Q is equal to Cv, then V is equal to Q by C, then delta Q by C, delta Q is delta IL divided by 8 into Fc. This one is the ripple voltage. If you want to reduce the ripple voltage, so this one is C. Ripple voltage, you will increase the capacitor. If you want to reduce the ripple current of inductor, then you increase the inductance value. To design of a buck converter, so you decide this one. You decide what will your V in, what will your output, and what will be output current is the power you define. Then two things is inductor design of inductor and design of capacitor. Both are depending on the ripple current and ripple voltage. Inductor defined by the ripple current, and capacitor defined by the ripple voltage. What amount of ripple you want to keep in your circuit. In normal condition, delta IL take is 20 to 40%, and delta Vc will take 2 to 5%. Below below this one, because of you have required the constant output voltage. Because of a Vc is same as a V naught. In the circuit, you observe this like Vc is same as the V naught. If a Vc is a ripple in Vc, then V naught also same ripple. Then you should require to reduce the ripple as much as possible. It means the ripple will be as low as possible. Take. I think 1 to 2% is a maximum. But normally, in normal cases, because if you take 1% of VC, then our capacitor will be bulky. If you reduce this one ripple, then inductor will be bulky. To minus this one, then inductor can take as 20 to 40%. Sometimes it will be 10% also, and this will be 1% or 0.1% something in some applications. Can reduce a delta IL, no, but delta IL is same as this one. Can reduce and find delta IL. You calculate here C value. Delta IL divided by delta VC into 8F. And what will be L inductor value, V output, so Vs minus V2 into D divided by F into delta IL. This one. Can design a buck converter to provide this one. Duty ratio, you know about duty ratio, dVs, you can find duty ratio here, V output by Vs. Boundary condition is and critical condition is remaining. I will teach you in next session. I am stopping here of this session. And boost converter and buck boost converter two are remaining.
Sir, one doubt, sir.
Yeah.
Is it in a Fourier series we were discussing for a square wave of this?
Yes.
The output of, in there we are calculating an IN for calculating the displacement power factor. We need to calculate ISM RMS by IRMS.
Yes.
For I source RMS we found to be I naught. Suppose I1 RMS, how you are calculating this? By substituting n equal to 1 to the standard x.
Yeah, IS RMS you can calculate a fundamental RMS.
Yes, sir.
But
You need to take square root of 4 I naught by pi sin omega t. Squaring and taking root of the term. We need to go like that.
here,
Yes, sir.
you know about the sinusoidal RMS, na? Vm by root 2.
Oh, so with that we can, okay.
You
We
can
will
directly
substitute that.
yeah. Don't need to do this one.
Oh, then it will be sin 2 omega t and
Sin omega t plus
for
minus.
fundamental component. Okay.
This one is not affected in RMS value.
Okay.
You can
For,
directly take a Vm by 2 maximum value by root 2.
I was thinking about other components. Sir.
No.
Okay. Thank you, sir.
In a fundamental case, all of things is same in sinusoidal. Sinusoidal, cosine. Okay, everyone.
Thank you, sir.
Thanks to all.